again to everyone. So in the previous classes, we have discussed about some of the resource allocation algorithm. But once the resource allocation is done, then the process of task scheduling takes place. The main objective of the task scheduling algorithm is to determine the order of execution of the task. Like if you remember operating system process scheduling, so you have studied so many algorithms like first in first out algorithm or FCFS algorithm. Then you have studied about shortest job first. Then you have discussed about about round robin algorithm and shortest remaining time first and other scheduling algorithms, right? So if you see these algorithms, and if you take an assumption that number of tasks are arrived at the same time, for example, 5 different tasks are arrived at the time 0. So you can schedule them in any order, right? Because their arrival time is same, right? So here, what exactly we are doing, we are determining the ordering of the task, in which order we need to process the task so that our objective is going to be fulfilled. Like if you recall operating system process scheduling, there our objective is turnaround time or average turnaround time. And we have also seen waiting time, response time, and other parameters, right, which are there to evaluate different task scheduling, different process scheduling algorithms, right? Similarly, in the cloud computing, just an extension of that scheduling algorithm, here we deal with multiple processor. Right? There you have one processor. Like you given a set of process and their burst time. If I ask you what is the completion time of 5 different processes, then the time is same, right? For example, if I take P1, P2, P3, P4, and P5, and their burst time is, let's say, 1, 2, 3, 4, 5, then irrespective of the algorithm, all the processes are going to be completed at 15 unit of time, right? You can sum this thing, you will get 15. Whether you use a FIFO or SJF or RR or SRTF algorithm, because you are dealing with only one processor, right? We consider that there is only one processor who is executing these different processes. But when you go for parallel distributed computing or cloud computing, or you can say grid computing, utility computing, in those cases, you can find that there are more than one processors are available, right? So when more than one processors are available, this completion time is not same with respect to the different algorithms, right? So if you use one algorithm, maybe you are getting the completion time is the least one, or in some cases you can get completion time is not good, right? So with respect to different algorithms, the structure may be different, right? So you can consider these processors are nothing but virtual machines. Some examples we consider, these processors are nothing but the clouds in a broad term, right? So let us see how actually we deal with the task scheduling algorithm in cloud computing. So you know that there are 3 different types of services we have, that is called as infrastructure as a service, platform as a service, and software as a service. So if you see, these scheduling algorithms are actually comes under the infrastructure as a service. As the service is with respect to the hardware components or the processors, or you can say CPU cores, or we can say servers or workstations or VMs, or in a broad term data center and cloud. So we refer this as an infrastructure as a service cloud. So here, if you particularly focus on IaaS cloud, where each and everything is provided in the form of virtual machines. Like if you see Amazon EC2, right? That is a infrastructure as a service cloud. Amazon S3 is also a infrastructure as a service cloud. So they are actually providing you the infrastructure, right? Infrastructure in the form of storage, infrastructure in the form of compute, infrastructure maybe in the form of network also, right? So by creating a VM or a you can say virtual object or you can say virtual storage, they are providing you the resources. So in infrastructure as a service, the resources and services are provided to the user in the form of leases. So there is a difference between the lease and task. Lease, as I said earlier in the resource allocation, if you remember, lease is a formal document, right? But task is not that much formal. Okay, for lease case, you are specifying details of everything, right? You need to start at this, you need to end at this point. What is the cost of executing this particular lease that you have to determine, right? So here, basically, the resources and services are you will get in the form of leases. And you can also, user can access these services and resources uh, by the help of the VM, which is created by the cloud service provider by taking the resources of the physical machine. So the users can control the resources safely because of the efficient virtualization solutions. We have seen the virtualization technologies, one of the very popular technology that we are using that is called as VMware. Similarly, we have KVM, we have XCN. So actually these are nothing but the virtual machine manager, or we call this as a hypervisor. So basically, they are actually controlling the virtual machines, which is created on top of the physical machine. And one of the advantages of this IS cloud is that the computational capacity provided to the end user are very flexible and efficient. That also we have seen in the form of elastic block storage. In elastic block storage, we took earlier 8 GB and later point of time, if you want to extend it to 100 GB, so that is also possible. That is going to provide you the flexible nature of the cloud. Like if you take an example of Amazon EC2, which we have already seen, there you can create VM. In also these VMs are provided in different tier, and these VMs are also having different. They're providing different requirements, right? Accordingly, the cost is also varies with respect to the type of VM you have created in Amazon EC2. So VMs are leased to the user at the price of 10 cents per hour. Cents is another unit of cost. So actually 100 cents is $1. So 10 cents per hour means it is 1 by 10th of the 100 cents. So that means per you can pay 6.13 rupees for the 10 cents, right? So with paying this minimal amount, 6.13 rupees is a very nominal amount that you have to pay for user, right? Again, different pricing schemes are there, different, you can say different instances are having different price. With respect to that, it can actually vary. Now, each VM, if you see in a particular case, you can see the VM offers you an approximate computational power of 1.2 gigahertz Optron processor. Like you can go to your my computer properties and you can see that what is the properties of your computer system. There also you will find some gigahertz. Like one example I can give you, one computer is having 2.90 gigahertz. Here I'm talking about 1.2 gigahertz. With respect to the power of different systems, then this frequency, you can say it is varies. And also this virtual machine provides you 1.7 GB of memory and also provide you 160 GB of disk space. So here we are particular to a specific physical, specific virtual machines. but these units actually varies with respect to different instances. For example, when a user needs to maintain a database, so we have a service called DynamoDB. That service we can opt if we want to maintain a database. Suppose in that database we need some space with respect to month. First month we require only a very less space, but as the system grows or as the number of employees grows in the system, so definitely we need to extend the disk space. So we can rent a number of VMs from the cloud and return them after that month. If there is no use, if you need the database for a particular month, but you don't want to continue in other months, right? Because you have your own business strategy, then you can return them or you can release the VMs and you are not going to be charged for the month which you have not in which you have not used the services related to the database. So what user can do, user can minimize the cost by the help of these type of you can say resource allocation, or you can say you can decide that what is your tenure to use a particular resources. So user can also add and remove resources from the cloud to meet peak and fluctuating service demands and pay only for the capacity used. So that is called as your pay for usage model. So through that you are going to pay, and you need not pay any upfront cost. There is no upfront commitment, and there is no extra charge is going to be charged to you. Like Amazon is having its billing dashboard. You can visit to the billing dashboard if you have created the account, and you can see that what is the amount they have charged based upon the usage of the resources. So cloud computing is emerging with growing popularity and adoption. However, if you look into different data center, like Amazon case, we have discussed about availability zones, we have discussed about regions, we have talked about data center. But if you look into these data centers, that there is no data center having unlimited capacity. For example, you can say this is one data center, let it be DC1, and this is another data center, DC2, another data center, let's say DCN. Like that, we have n different data center. For example, the capacity of the storage capacity of data center 1 is, let's say, XGB, right? The storage capacity of data center 2 is, let's say, YGB, and storage capacity of DCN is ZGB. So if a user has requested storage to data center 1, so out of this XGB, let us assume that X minus X dash GB is already consumed, right? Means that the storage is already assigned to those user who have requested before this particular user. But if this user demand now X minus X dash GB is suppose used, whatever remaining GB is there, okay, remaining GB and remaining GB in the data center, this user is asking more than that remaining GB. Like if you talk about 100 GB, let's say 50 GB is adjusted, okay, another 50 GB is remaining. But the requirement of this particular user is, let's say, 55 GB. So this data center 1 cannot assign the resources, okay, to this particular user, and the requirement is more than the availability, right? That's why we say that there is no data center having unlimited capacity. Every data center has a finite capacity. The only thing is that we cannot ask for whatever remaining is there in a particular data center. We are not asking beyond that one. We cannot ask. That is not our requirement. Like if I talk about, let's say 20,000 TB, right? That much storage is not required, right? If it is required, then we can think, right? But as a normal customer or a user, we require some TB, not 20,000, 30,000, or more than that GB. So what this data center is going to do? This data center is going to collaborate with the other data centers, right? Just like you have seen a topology where one node is connected to each and other nodes. Similarly, these data centers are connected to each other. So when the requirement is high, then whatever the availability in that particular data center, one data center is approaching another data center to get that resources, right? For example, DC1 can make a request DC2 to provide 5 GB. So together this 50 and plus 5 can satisfy the requirement of this user. So a user can be assigned 55 GB of storage from data center 1. That's why it says that in case of significant client demand, because client demand always varies with respect to time, right? So in case of significant client demand, so it may be necessary to overflow some of the workload to another data center. So you can say this customer that I can provide 55 GB, 50 GB you can store in data center 1, the rest 5 GB you can store in data center 2. So here you can see as the client demands is more than the availability. So what we did, the overflow workload is your 5 GB, right? So that workload is sent to another data center, right? That data center is going to provide 5 GB of storage. In that context, we say that there is no data center having unlimited capacity, right? Now, these workload sharing can even occur between different deployment models. Like we have seen different deployment model as, let's say, public cloud. We have seen private cloud. We have seen community cloud, and we have seen also hybrid cloud. So you can say, moreover, it is an hybrid cloud which takes either public, private, or public community or private community to provide the resources. So this workload sharing between different data center occurs between the private cloud and public cloud. You can say hybrid cloud, or among the private cloud or among the public cloud as well. So you need to collaborate. One data center, for example, this data center is owned by X company. This data center is owned by Y company. So what happened here? X company, Y company, both needs to actually collaborate each other to provide resources to the customers, right? So collaboration is required between two different cloud. And workload sharing is able to enlarge the resource pool, provide even more flexible and cheaper resources, right? For example, this data center is having, let's say, 200 GB, right? And this data center is having 100 GB. So they together having 300 GB, right? So definitely the resource pool is enlarged. Earlier the resource pool is having only 100 GB, but now the resource pool having 300 GB. And suppose these two service providers are collaborate together, then customer will get the service in cheap rate, right? So whatever best is there for X provider, people will choose. Whatever best for Y provider, people will choose. That will provide more flexible and more cheaper resources to the customer. And to collaborate the execution across multiple clouds, the monitoring and management mechanism is a key component. That you need to regularly monitor, right, whether the service is going to be provided from data center 1 or it is going to be provided from data center 2. And management, it plays also very important role. It also requires, you can say, provisioning of the resources. It also requires scheduling, monitoring, and failure management. Okay, if you increase the resources and if you collaborate, then you have to look into the fault tolerance as well. So maybe your resources may be failed, right, due to some issues also that you need to immediately identify, and also you can rectify. One of the example, if you see a very famous example, that is called as Open Cyrus. So it is a cloud computing test bed. Whenever you go for research work, you will see that people usually generally uses a test bed. Okay, testbed provides a infrastructure to conduct the simulations, or you can say experimentations. So this cloud computing testbed consists of 14 geographically distributed data centers. So total 14 different servers are located in different part of the world, right, to provide the resources. And these 14 distributed data centers are not following the same time zone. Like, the time zone of each and every country is different, right? So they are under different time zone. They are also not under the same organization. Okay, they are under different administrative domains around the world. So see the complexity, right? Like number of time zones and number of administrative control, number of policies are embedded into a single test bed. Is open silos, right? And each data center, if you look into, like total we have 14, and in each and every data center manages at least 1,000 cores independently. So total you have 14,000 plus cores, right, to provide the resources. Why we are deployed in different data centers in different places? The reason is obviously the advantages of distributed computing, right? We says that if a failure happen or a natural calamity happen in one of the location, it is not going to impact the other location. Okay. Like if I make a centralized unit, if something happens, then the network is going to be collapsed, right? But when it is go for a distributed system like open silos, if a system is failed, it is not going to impact other domains. So for this task scheduling problem, we consider infrastructure as a service cloud system, and there are number of data center participated in a federated approach, federated combined approach. Okay. So more you can say each and every data center is owned by different cloud service provider, and they collaborate each other to provide the services. And these data center deliver basic on-demand storage and compute capacities over the internet. So if you look into each and every data center, it delivers storage, also the computational capacities over the internet. You can ask for storage, you can ask for computation also, right? And the provision of these computational resources are in the form of VMs, right? So each and every virtual machine is having two different requirements. One requirement is the computation. For example, a VM may ask, like I mentioned here, 2.9 gigahertz of some processor, like Opton processor I told you. In the storage case, it requires suppose 1 GB of memory, right? So these VMs are the requirements that you need to fulfill by taking the resources of the data center. And these resources within a data center actually form the cloud. Cloud is nothing but the data centers, right? Sometimes there is no clear cut, you can find the difference between the data center and cloud. But a cloud service provider is having more than one data centers. In fact, it is quite more data center to provide the resources. And VM is an abstract unit of storage and computing capacities provided in a cloud. And without loss of generality, here we assume that VMs are from different clouds or offer different types of services. Like if you talk about data center one, in data center one, if you see one particular VM, and if I take data center two, I'll pick another VM, they are having different characteristics. Their structure is different. Okay, their computational capability is different, their storage capacity is different, their price is also different. That's why we call it heterogeneous VMs, each of which has different characteristics, right? So they may have different number of CPUs, like each and every VM's number of cores may be also different, memory may be different, bandwidth may be different, and other components, whatever you have seen in Amazon EC2, they are different from one VM to another virtual machine. So the computational characteristics of different CPUs may not be same, right? Not only the requirements is different, but also the resources are also different. So in order to solve this particular problem, how to combine a set of data centers into a single platform, although they are distributed, but there is a need that they need to collaborate each other to provide resources to the customers, right? So here we assume that each and every cloud has a manager server. So if you consider a set of cloud like C3 up to C1, C2, C3 up to Cn, then each and every cloud service provider or cloud is having a manager server. Okay, what is the role of this manager server? The manager server actually keeps track of information about the current status of the virtual machines. They are looking into current status, whether the VM is active or the VM is idle or the VM is in sleep mode or it is in the shutdown mode. Okay, that is the status is with the manager server. So whenever an application which consists of a set of tasks, application is nothing but we consider a directed acyclic graph, right? For example, I can say this is one of the application. Okay, so this application you can say this is your task 1, this is your task 2, this is task 3, task 4, task 5, task 6, and task 7. So a particular application, let's say the application is A, is having seven number of actually seven number of tasks, right? So when a particular application arrive to the manager server of the cloud, okay, manager server is handling or monitoring it, right? That's why they arrive to the manager server of the cloud. Manager server communicates with other manager server. I told you with respect to each and every cloud, we have a manager server. Suppose this manager server fails, manager server of C1 fails, that alone it cannot be executed in C1, the cloud 1. Then it need to collaborate with the manager server of other cloud. Like it will communicate with C2 manager server as well as C3's manager server. Okay. So why actually it interacting with each other? It has to decide which task is going to be executed in C1, which task in C2, which task in C3, and so on. So if the tasks are going to be executed in C1, then it is queued in C1. But if the task is going to be executed in C2, then it is going to be queued in C2. So the tasks are queued in the respective cloud and executed when sufficient number of VMs are available. So one task may require multiple virtual machines also, right? It may require multiple virtual machine also. So when the tasks are queued in a respective cloud, we'll check their requirement. Whenever that much resources or VMs are available, then only it is going to be executed in their respective cloud. And when a particular task is successfully executed, the corresponding VMs associated with the task is going to be released and resources are also released. If you need any additional resources, that you have to release it. Now, this task scheduling model consider the application in two different modes. Like in resource allocation, we discussed about the different types of mode. We discussed about advanced reservation mode, best effort mode, immediate mode, negotiated mode. Okay, a lot of different modes I told you. So similarly, here each and every application can be submitted in two modes, either in advanced reservation mode or in the best effort mode. So you know that advanced reservation mode is having more priority of the best effort mode. At the same time, a advanced reservation task cannot preempt another advanced reservation task. Similarly, a best effort task cannot preempt another best effort task. Okay, but if there is a B task executing in a particular cloud, at the same time AR reach to that particular cloud, then that advanced reservation task can preempt the best effort task on its arrival because AR is having more priority over the best effort task. But once a best effort task is preempted from a particular cloud, it is going to be rescheduled to the same cloud only. And whenever sufficient virtual machine is available in that cloud, then only it is going to be again resumed in that particular cloud. Okay. And as I said already, if you go install Hygia in your system, Hygia is a popular open source VM based lease manager or resource manager. So in that case, you can really see how actually the advanced reservation and best effort modes are working together, and resources are provided to these different modes using AR and B based upon the customer requirement. So here we introduce a very simple problem. We consider there are m different clouds, that is C1, C2, C3 up to Cm, and we consider n different applications. Like I mentioned, each and every application is a directed acyclic graph. So you can consider each and every customer submits a directed acyclic graph which comprises of a set of tasks that need to be executed in different cloud. So an application is, you can say, consists of a set of tasks, but these tasks are not independent tasks. Okay, like if you go for directed acyclic graph, you know they are having precedence constraints. Precedence constant means they are having priority. One task is having priority over another task. So you have to follow the precedence constants. Like if I take a directed acyclic graph like this, then you can say until unless A is going to be completed, you cannot start B and C, right? Because the execution of B and C is actually dependent on A. And if you go for instruction level, you can say suppose A is computing C is equal to A plus B, and once C is computed, then suppose B is going to evaluate C plus A is equal to D, whereas C is going to evaluate D is equal to C minus B. So until unless you will get the value of C from the node A, which is the root node, then you cannot execute B and C, because B and C are dependent on A. So here each and every application consists of a set of tasks, that is T1, T2, T3 up to TP, with their precedence among the tasks. They have precedence constant. Precedence means dependence, like BC are dependent on A. They cannot be executed. Even if there is sufficient resources you have, you cannot execute it. Like you have studied one important concept in computer architecture, that is called as a speed-off factor, right? Sometimes people think that if you increase the number of processors, then the performance is going to be improved, but that is not practically true, right? Sometimes, like for example, if you take this directed acyclic graph into consideration, like if I deal with only one processor, if I go with one processor, first I need to execute A. Once A is completed, I can start B or C in any order, right? So with one processor, let's say this is the performance, right? Or let's say you have finished at this particular period of time. But when I increase the number of processors to two, okay, instead of one processor, if I take two different processors, then you can say A is going to be executed in processor one. Once it is executed, I can start B in the first processor, as well as I'll start C in the next processor. And let's say this is the communication time from A to C. Because A has to send some results to the next processor, which takes time. But as A and B, they are also dependent, but there is no time gap, because the same processor holds the result, so it can directly give to the B. So if you consider this particular situation, obviously the performance of it of two processors are obviously better than the one processor. But when I increased it to three different processors, right? I have three processors in my system. So I can execute A in my first processor. Once it is done, I can start B in that same processor. With some buffering time, I can start C in another processor. Let's say B finishes here, C finishes here. So if you see for this particular directed acyclic graph or a simple directed acyclic graph, even if you have more than two processors, the performance is not going to be improved, right? That's why we are calculating the performance with pipeline processors and non-pipeline processors. By calculating that, we can decide what is the speed of factor. So don't think that increasing the number of processor is going to increase the performance of the system, right? Like here you can see the performance is not going to be increased. It is not improving if you increase the number of processors two onwards, right? Whatever performance you will get in two, you will get the same performance in 20 processors also, 100 processors also, 200 processors are also there. So there are some laws are also there. If time permit, I'll tell you. One is called as Amdahl's law, another is called as Mustaphan's law, right? So these laws are there with respect to the speed of factor. Okay, here our objective is to say that you are given with different applications like this, which comprises of a set of tasks with precedence constants among the tasks. And the number of tasks with respect to two different applications is different. Like one application A1 is having 5 tasks, whereas application 2 is having 10 tasks. So they are not identical with respect to the number of tasks. And their requirements are also in fact different. So you can say AI intersection AJ is equal to 5. But AI mode is not equal to AJ mode in the sense that the number of tasks in AI is you can say not necessarily same as number of tasks in the another applications. Whereas if a task T1 is part of A1, it is not a part of another applications because each and every application is independent. They are not dependent on each other. Right? That's why AI intersection AJ is equal to 5. And we represent each and every vertex. Let's say vertex bi belongs to the set B, which is a set of vertices. Represent the task, and we consider an edge PMN that indicates that there is a edge from vertex M to vertex N, and that is a part of your set of vertex. It represents the dependency or precedence among the task BM and BM. If there is a edge between BM and BM, that indicates that BM is need to be executed first, BM need to be executed afterwards, right? So the task BN can only be scheduled after BM has successfully completed and it releases all resources associated with it. However, these applications, as I said, they are having different arrival time as well as they can be submitted to the cloud in different modes like advanced reservation mode and best effort mode. Obviously, advanced reservation mode means you have to pay more. Best effort mode means you have to pay less, right? Because best effort modes are a little bit flexible in comparison to the advanced reservation mode. Yes, you can see this picture. This picture will summarize whatever I want to tell you in graphical way. Like here you can see, let us consider this is my cloud 1, or you can say data center 1. It is my cloud 2, it is cloud 3, and let it be cloud N. Okay, we have N different cloud service provider, or you can say clouds, or you can say data center. And each and every cloud is having different type of processes. Like here you can see cloud 1 is having the number of processors. One of the processor is having CPU 2.8 gigahertz dual core processor. Memory is 2 GB and disk space is 30 GB. And network bandwidth is 1 M. Similarly, but if you go for cloud 2, it is also having number of processors, and one of the processor specification is that CPU is 1.7 gigahertz and it is XeON processor, and memory is 1 GB, disk space is 160 GB, network bandwidth is more, that is 100 M. Like that, each and every cloud is having different type of servers to provide these resources. And as I already said, each and every cloud is having a manager server. You can look into each and every cloud. We have a manager server. The role of manager server is to keep track of the virtual machines under a particular cloud service provider. That's why whenever you want to migrate the load from one cloud service provider to another cloud service provider, so you have to see the interaction between two manager server. Let's say Cloud 1 wants to interact with the Cloud 2, then the manager server of Cloud 1 is going to interact with the manager server of Cloud 2. Whether resources is available in the Cloud 2 or not, that they will need to communicate. If they agree, then some of the loads is going to be migrated to the other cloud service provider. One CSP to another CSP, you can migrate, right? So now you can view this model in two ways. You can go for a centralized model. As I said, the collaboration may happen between the public cloud as well as the private cloud. The collaboration can happen between two public cloud. It can be happen between two private cloud also. So if you go for centralized model, let us consider there is a centralized manager here, right? So we call this as a centralized manager. Okay, we consider that is a centralized manager. So whenever one manager server wants to communicate with another manager server, it has to go through that centralized manager. In fact, whenever a cloud service, whenever a customer wants to submit his requirement, his or her requirement, then that need to be submitted to the centralized manager. So just like manager server, centralized manager is also responsible to know the resource status in each and every cloud. And the status may be provided by the manager server. So one customer has to send his requirement to the manager server. Okay, sorry, centralized manager. Centralized manager has status of each and every cloud through the manager server. And the centralized manager will decide whether to redirect this particular request to the cloud 1 or cloud 2 or cloud 3, so on up to cloud n, based upon the resource availability, by making surety that no cloud is overloaded, no cloud is underloaded, right? So in that case, centralized manager plays a very, very important role, right? But the problem with this model is same age. As there is a centralized model, you may face a single point of failure. Single point of failure, which we call as SPOF. Okay. So if the centralized manager is failed, then the whole network is going to be failed, right? So in order to avoid this one, you can think about a distributed architecture. In distributed architecture, there is no need of any centralized manager. We do not require any centralized manager. In fact, this customer request is going to reach to the manager server of one of the cloud. Let's say this customer is near to is submitting the request from our country, and let's say this cloud is also hosted in our country. So the request is going to be redirected to our own country server, okay, or data center. But if this cloud service provider or data center or this manager server feels that we cannot execute all the tasks submitted by a user in the form of an application, so some of the requests can be migrated from one manager server to another manager server. Okay, so one manager server is coordinating with another manager server, okay, communicating with another manager server to redirect some of the loads to the manager server, right? In this way, actually, we perform the different migration, but this is not a centralized model. This is completely a distributed model. You can see in this picture, it is more clear. For example, if I say this is one of the application. Okay, this is one of the application. Okay, application is represented in the form of a directed acyclic graph. We have A, then after A you can execute B as well as C. Then B okay is connected to D, C is connected to also D, and C is also connected to E, and D is also connected to E. Okay, the same picture I have drawn here for better visualization. Okay, see this one. This particular application is reached to the customer, reached sent by a customer or requested by a customer to the manager server of one of the cloud. So this application reached to the manager server of one of the cloud. That manager server feels that the whole application cannot be executed by its own cloud. Okay, so what it decided? It decided that the task A, okay, the task A and the task D is going to be executed by its own cloud, and rest of the task is going to be migrated to other cloud, right? So you can see here A and D is going to be executed in its own cloud. So it is going to be it is going to be queued in that particular cloud. And prior to arriving of A and D, other tasks are also queued here, right? Other tasks are also queued here. So A and D, okay, A and D is added in the bottom of the queue or in the rear of the queue, right? So once sufficient virtual machines are there, then A and D is going to be executed. Wherever suppose we assume that E is going to be transferred to another manager server. So one manager server has to coordinate with another manager server, request that manager server that part of my application need to be executed in your cloud, right? If that manager server agrees to provide the resources, then that particular task is going to be transferred to the agreed manager server. And once it is reached to this manager server also puts the E, the rear of the queue, okay? And whenever the sufficient virtual machine is available, then it is going to be executed, right? Similarly, you can also coordinate, like you know that you cannot start E until unless you know the result of C, right? Again, C is also dependent on A. So once A is successfully completed by this manager server, the manager server has to send the result to the manager server who holds the C. Okay. And that manager server, suppose in another cloud that is handling C, right? We have sent to them. Once it is executed C, this manager server executes C, that result it has to send to this manager server. Then only this particular manager server can execute the task E. So whenever there is a dependency, there is a interaction between manager servers. Otherwise, it has to wait for an infinite period of time. Okay, once you provide the result, then only it is going to be evaluated. Otherwise, it is not possible to evaluate these different tasks in different clouds, right? So this is the process actually we are following. When a client submits his or workload, typically in the form of an application or directed directly graph to a cloud, the manager server first actually partition the application into several tasks. This partitioning is also very much important, right? Like if you talk about a software, that software is also having different modules. These modules are having the issues related to cohesion as well as coupling, right? They may be dependent on each other. Okay, there is a dependency between different modules. There may be a different kind of function calls also. So dividing a application into a number of tasks is also a very important process, right? So once the manager server partitions the application into several tasks, the manager server is going to decide that actually which cloud is going to execute this particular task. Okay, whether cloud 1 is going to be executed or cloud 2 or cloud 3, that you have to decide. Okay, and this information, what based upon some information only you can decide whether first manager server is going to execute, or the second manager server or nth manager server is going to execute. Okay, so this information you have to collect from all other manager servers, right? Once you know the status of each and every machine, then only you can decide whether to execute in X cloud or you can execute in Y cloud. Because sometimes you can see also there is dependency between different tasks, right? All the tasks are not independent. Sometimes you may find independent task in one level, but as a whole application, you will not see they are independent in nature. So if the manager server assigns to its own cloud, as I said, it will store the task in the queue. And whenever sufficient resources are available, as well as the data is also ready, then the task is going to be executed, right? But if the task is, means if the resource is ready, data is not available also, you have to wait, right? Like I told you here, if you see, the task D can only be executed once you get the result of B and C. Let's say D you have assigned to some cloud, it is ready to provide the resources, but the data is not ready. Then you have to wait. There is no other option, right? So if the manager server of a cloud A assigns a task to cloud B, okay, the manager server of cloud A assigns the cloud B. So there is a migration from cloud A to cloud B. So the manager server B has to check whether its resource availability can meet the requirement of this task or not. Because cloud B is also having a queue, is also receiving the request from different customers. Cloud A is also receiving from different customers. So if you want to migrate, cloud B needs to check that how many requests are pending in the queue. After assigning the resources, can I provide some resources to the task submitted to cloud A? So if the answer is yes, then the task will enter to the queue of cloud B. Cloud B is going to accept that load, and that is going to be added into, you can say, in the waiting queue for its execution. Otherwise, the manager server of B is going to reject this particular task by saying that no, it is not possible to provide resources, because the you can say, the task arrived earlier, occupied all the resources under cloud B. That's why this transfer cannot be done. So in that case, cloud A is going to request other clouds like cloud C, cloud D, or other clouds to get the resources. But before a task in the queue of a manager server is about to be executed, the manager server actually transfer the disk images to all computing nodes that provide enough VMs for task executions. Right? So, like suppose you want to transfer, then also you have to see that the temporary files or the associated files which requires for the task execution, that actually need to be available in order to execute that particular task, right? That's why I told you that not only data, but also this disk images and other things are also need to be available in order to execute the task in a particular server. So let us take a very simple example to understand actually how this scheduling actually take place. Now you can take an example of these three applications. So let us consider these applications as application 1, this is your application 2, and this is your application 3. Okay. If you go for application 1, which I represent here as A1, you can see in A1 we have number of tasks is 5. Okay, if I see the number of tasks is 5. If you go for A2, the number of tasks is 4. Okay. If you go for A3, the number of tasks is 3. That's why I told you while defining the problem, the number of tasks in a particular application is not necessarily equal to the number of tasks in other applications. Like A1 is having 5, A2 is having 4. So they are not equal, right? And if a particular task, like you can see the task A to task E, I'm writing A hyphen E, then task F to task I, and task J to task L. So they are part of A1, A2, A3 respectively, right? So if a particular task, suppose like I consider task B. Task B is belongs to application 1, right? Task B is belongs to application 1. So it should not be part of other task, right? It should not be part of other task. That's why AI mode, right? Or if a task is belongs to application AI, it should not be in another task. That's why we say AI mode is intersection of AJ mode is equal to 5, right? Like you can see B is a part of AI, so B should not be part of A2, A3, and other different tasks. Okay, and you can see also different tasks are also arrived at a different time, right? For example, arrival time of the application 1 is 0. Arrival time of application 2 is 3. Arrival time of application 3 is 9. Their arrival time is also different. First is different applications are there. They are having different dependencies, right? And they have different arrival time as well. And each and every application is also submitted in different mode. Like if you see the application mode of the first application is best effort. Second application is submitted in AR mode. Third application is submitted in the best effort mode. Right? First one is BE mode, second one is AR mode, third one is BE mode. Right? So their application order is different. For example, while if you are executing a task B, right, which is a B task, at the same time, AR task is arrived to your system. Okay, then what you have to do? AR task can preempt B task, because you know advanced reservation task is you can say it is having more priority over the best effort task. Okay? However, B cannot preempt, AR cannot preempt each other, right? And these set of tasks need to be assigned to 3 different cloud. Like here I consider cloud 1, cloud 2, and cloud 3. So you can consider n number of clouds. For the simplicity of experiment, we consider 3 different clouds. Right? So you can see total number of tasks we have A to L, right or no? Here you can see total number of tasks is A to L. And number of clouds is 3. Right? So you have to assign these tasks to 3 different clouds. As I said earlier also, the requirement of these 3 tasks is different. Okay, sorry, requirement of these these tasks are different, and the resource capacity of each and every cloud is also different. Right? Now you have to decide if there are A to L number of tasks. If I can choose cloud 1, I can choose cloud 2, I can choose cloud 3. So you can map with 3. Just like suppose you want to purchase a particular product, and if you have 3 different shopping malls, so you can compare the price in 3 different shopping malls, right? Then you can decide the shopping mall which is providing you less price, you are going to pick that product from that shopping mall, right? Similarly, here each and every task has 3 options. They can be executed in cloud 1 or cloud 2 or cloud 3. Okay, but the requirement is same for task A. If you submit to cloud 1, the requirement is same only, right? B, the requirement is same. But the computational capacity of each and every cloud is different. So as the computational cloud is different, you will get a different execution time in different cloud. Like sometimes you can run a particular application in Linux environment. You will get the execution time is different if you execute the same application, same software or application in Windows platform. Okay, with respect to different platform, the time taken to deal with a particular application is actually different, right? So, for example, if task A is going to be assigned to cloud 1, then it takes, let's say, 2 unit of time. So you can assume that a 2 unit of time means it may be a 2 second, it may be 5 second, it may be 5, 10 second. So randomly I'm saying it is 2 seconds, right? 2 unit of time. Any time unit you can choose, second, minute, hour, you can consider day, anything, right? But if the same requirement is given to C2, it is taking 3 unit of time. There's no number of processors, number of cores, storage, computational capability. These all are different with respect to different cloud. Similarly, if you go for C3, it is taking 5 unit of time. C1 is taking 2 unit of time, C2 is taking 3 unit of time, C3 is taking 5 unit of time. That's why we call this is a heterogeneous one. But if it is homogeneous one, what you will get if you execute in C1, C2, C3, suppose a C1 takes 2 unit of time, then C2 takes 2 unit of time, C3 also takes a 2 unit of time. Okay, because they are in homogeneous structure. Their configuration is same. Like consider two different identical machine. Okay, you are executing a C program or Java program or Python program. More or less, you will get the same time if they are having same configurations. But if the configuration is different, then you will get a different time. Okay, you will get different time. So now here you can see that there are, I think, total 5 plus 4 plus 3. So it is 12 different tasks that you have to assign to 3 different cloud by assuming that this is the time actually taken by each and every task in a particular cloud. Okay, that's why we call this as a heterogeneous environment. And as we are dealing with multiple cloud 1, cloud 2, cloud 3, so we call it a multi-cloud environment. Okay, first one is it is a heterogeneous environment. Sometimes we call it a heterogeneous multi-cloud environment. So there are numerous algorithms developed over a period of time to assign these tasks to different cloud, right? But make sure that you are executing these tasks based upon whatever mode is given to you. Like here, the mode is given as B for the first application, AR for the second application, and B for the third applications. Third application, right? So there is two popular algorithm. First algorithm is called as RR, that is called as round robin algorithm. Second algorithm is called as list scheduling. First one is called as RR algorithm. Second one is called as list scheduling algorithm. Right? So using these two algorithm, first we'll try, then I'll tell you the third algorithm. Okay. So using round robin algorithm, what you have to do, you have to assign 12 different tasks to 3 different clouds. Okay. And you have to calculate what is the total completion time. As you are dealing with 3 different clouds, you have to calculate total completion time. What is the total completion time to assign these 12 tasks to, you can say, 3 different cloud. Okay. So can you please try this one, that you know that round robin, how it actually works, and take 3 different clouds and assign it to 3 different clouds. Okay. I'll tell you how to do it, then you can try. Otherwise, I'll solve here. Okay. So if you go for RR algorithm, right? So you know there are 3 different options you have: cloud 1, cloud 2, cloud 3. So you can assign task A to cloud 1, task B to the cloud 2, task C to cloud 3, again task 4 to cloud 1, and task 5 or E to cloud 2. Right? This we are actually doing in the round robin. Round robin means what? You will go for a circular fashion. 1, 2, 3. You have 3. If you have 4 clouds, then you can assign D to the 4th cloud. Right? If there are 3 clouds, so 3 is completed. One cycle is completed at task C. So I have started D in D as cloud 1. Right? Then once an application is over, again you have to start from beginning. You should not continue, right? You should not continue 3 from here. So you have to start again from 1. So F is assigned to 1, G is assigned to 2, H is assigned to 3, and I is assigned to 1. right? Similarly, J case, J is assigned to 1, K is assigned to 2, and L is assigned to 3, right? So now you know, if you go for a Gantt chart, let me prepare the Gantt chart, then you can solve this particular problem. So I have to take 3 different processors, and also one is for time, right? Let's say this processor 1, this is processor 2, and processor 3, right? So I can write here, this is your cloud 1, this is cloud 2, this is cloud 3, and this is time. Okay. So you can take the time like this. For example, you can say time is 0 to 1 unit, like 1 to 2 unit, 2 to 3 unit. Like that, you have to write 3 to 4 unit, 4 to 5 unit. Like that, you prepare a chart, right? And so on. So you know, you can assign the task 1, like a task A, to cloud 1. So I'm writing A here. A is assigned to cloud 1. B is assigned to cloud 2. C is assigned to cloud 3, right? Similarly, D is assigned to actually cloud 1. E is assigned to cloud 2. F is assigned to cloud 1. G is assigned to cloud 2. H is assigned to cloud 3. And I is assigned to cloud 1. J is also assigned to cloud 1. Okay? J, up to this one, okay? Is J. And K is assigned to cloud 2, and L is assigned to cloud 3. So total we have 5, 4, 3. Yes. Total we have 12 tasks. So can you assign based on their precedence constant? Also, you have to remember this is your best effort task. This is your advanced reservation task. This is another best effort task. Can you please try that? Assign these tasks based upon their execution time given in this particular matrix to 3 different cloud, and tell me what is the total completion time. Please try. Okay, take 5 minutes and try these task allocation in 3 different cloud. Otherwise, I'll tell 1, 2 tasks, then you can continue. Like first task, which is available here at a time minute 0, which is equal to this application 1, right? At 0 unit of time, application 1 is available, and task A is available, right? So I can start task A. So task A actually we have assigned to which one? Cloud 1. How much time it will take in cloud 1? It is going to take 2 unit of time. So I am starting A here, right? 2 unit of time. Now once A is completed, you can start B and C. And you have to remember 3 unit of time, another task is coming. That is A2 is coming into the picture. So now we are at 2 unit of time. So you can start task B. Task B is assigned to the cloud 2. So it takes 8 unit of time. So you can write B, 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 and B, 4 B's. And let me draw some more rows. Okay. So now it requires 8 unit of time. So I have assigned 8 unit of time. Let me write the timeline also. 6 to 7, 7 to 8, 8 to 9, and 9 to 10. Okay. And remember, at 9 unit of time, another application is arrived to the system. So now B is actually completed because you have assigned a 2 unit of time. You don't know whether it will be printed in future or not. Then C is going to be executed in cloud 3. So the time unit is again 8 only. So C, 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 C. Okay, total 8 unit of time. Okay, 8 C's, right? So as of now, A is completed, B is completed, C is completed. And until unless B and C is completed, you cannot start the E. E is dependent on B and C. And D is dependent on B. So you have to wait, right? Until unless uh, B and C is completed. And B and C is going to be completed 19 unit of time. So up to 9 unit of time, there is no other task you can execute of application 1, right? Now, if you go for application 2, right? Go for application 2. Application 2 is going to be arrived at 3 unit of time, right? And it is an AR application. So you can start F. F is assigned to which cloud? Can anybody said F is assigned to which cloud? F is assigned to cloud 1, right? So it is going to take 4 unit of time. So I can write F, 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 and F. Okay, 4 unit of F, right? Now, if you look into G, G can start only after F is completed. Okay, only F is completed, you can start G. And G is taking how much time? 8 unit of time. It needs to be executed in the second cloud, right? So let me increase the time then again to accommodate the task. So I can write 10 to 11, 11 to 12, 12 to 13, 13 to 14. Okay. So now in this case, G is F is completed. Okay. Now G need to be executed in which cloud? Cloud 2. Once after F is over, you can start G. Remember, G is an advanced reservation task, but B is an best effort task. Right or not? So what you have to do? You have to print this best effort task for 3 unit of time, and you can start G for 8 unit of time. 4, 5, 6, 7, 8. Okay. So G is going to be complete at G is going to be complete at 15 unit of time. Okay. Like that, you have to process, right? All other tasks. So B is now printed here. So these 3 unit you have to give to B once all AI tasks are completed. Okay, and it need to be executed only in the cloud 2. You cannot migrate to cloud 3 or cloud 1. So can you please calculate rest of the task and tell me what is the total time you are getting? Is it clear? The process is clear? Is it clear, or if you have any doubt, you can ask. Any question?
So, how did you know we have to preempt 3 unit of B?
See, B is already assigned at a 2 unit of time, right? So once F is completed here, then you have to start G. For G, you have assigned 2, second cloud, right? So I have to start G from here, okay, or G from here at this point, right? But I found that B is an best effort task. I already mentioned you, and G is an advanced reservation task. And you know, advanced reservation task is having more priority in comparison to the best effort task. That is the reason why I have printed the best effort task, okay, the best effort task, and I have started executing the AR task. Is it clear? Is it clear? Because not only you have to check their allocation, but also you have to see what is their mode, right? So B mode is best effort task. Is all tasks are in B mode. These tasks all are in the AR mode. So AR task is having more priority over the best effort task. That's why G is able to print B, okay, for 3 unit of time, because G is not ready before this particular period of time. If it is available, then you have to print it, right? So it is printed B for 3 unit of time, right? Rest 5 unit it is executed, and another 3 unit of time it requires in future to complete its execution. So I started G because G is an AR task and B is an best effort task.
So, sir, H will start from 15 to 16.
H, you are saying H, right?
Yes,
Okay,
sir.
H. Ah, yeah, exactly. So let me increase the timeline. So this is 15 to 16, 16 to 17, 17 to 18, 18 to 19, 19 to 20. Okay. So once G is over, then only you can start H. H in which cloud? H is assigned to cloud 3. So I have to assign H here. Okay. I have to assign H here at this particular period of time, 15, 16. Okay. Is it clear?
Yes, sir. Thank you, sir.
Yeah. Yeah. So, uh, okay, you proceed. I'm giving you some time. You try to solve, otherwise I'll solve this problem. Then we'll go for the next algorithm. Okay, what is the time you are getting? Anybody solve? Okay, let me solve. You can check your answer. Is saying 41. Okay, let us see whether we are getting 41 or not. You check your answer with me. Wherever you are find difference, you let me know. Okay. So okay, G is completed now. So you can see as B is printed, and once you get the result of B, then only you can execute D and E. So we need not worry about application one, right? Until unless B is completed, right? And here also G is up to this one. So once G is completed, then only you can start and H and I. But in the meantime, you can see at a time unit 9, okay, application 3 is arrived to the system. Okay, that is J, K, and L. So J is asking for 8 unit of time in cloud 1. So you can provide it because it is free. 1, 2, 3, 4, 5, 6, 7, and 8. So 8 unit of time I have given to cloud 1, right? And once J is completed, then you can think about K and L, right? But prior to this one, you can see G successfully completed its execution. Okay, G is completed its execution. So you can start H and note that this is also B mode and this is AR mode. Application 2 is AR mode, but the rest is B mode. So I can start H, right? H, I need to start where? In cloud 3. So I can start H here. How much time it will take in cloud 3? 6 unit of time, right? So H 2 time, 3 time, 4 time, 5 time, and 6th time. So let me increase the timeline to 21, 20 to 21. Okay, H unit of time. Okay, H is for 6 unit of time, right? At the same time, you can start I also. I takes how much time? Which assigned to which cloud I? I is assigned to first cloud. I takes how much time? 4 unit of time. So what we can do? I, you have to start here. Again, there is a conflict between I and J. Whether I can print J or not, can anybody say? I and J, look into their mode and tell me whether I can print J or not.
So you have to preempt J.
Yeah. So I is for 4 unit of time. So I'm writing 1, 2, 3, and 4 time. So J is printed 2 time. But rest of the time as it is. Okay, 1, 2, 3. It requires 8 unit of time. 6 unit of time it is already done. 2 unit of time I have printed. Because there is a dependency between G and I. A dependency between G and I. So it can only print a 2 unit of time. So now I think AFG HI is completed. I is completed. G is completed. Another E, H is completed. Right. So now what you can do once G is completed, you can resume B. Once G is completed, you can resume B, or B is for 3 unit of time, 1, 2, 3, right? Right or not? 3 unit of time. So B is now successfully completed. And until unless J is completed, you should not think about K and L, right? So B is completed, it's the execution. Now, once B is completed, you can start a D and E. D in which cloud? D need to be executed in cloud 1. So I and D, here there is a conflict. Is it possible that to print I by task number D, task D, D can print I or not?
No, sir.
No, because I is an advanced reservation task. So D cannot preempt. So D can start after I. But at the same time, you can see D has to wait, and J is already there in the queue. J is already there in the queue. J is also a BE task. D is also a BE task. So if there are two BE tasks in a queue, okay, the task which is partially completed, that will be given more priority. So J need to resume its work from here, 2 unit of time. After J, you can start D. Okay, so let me extend this one. Okay, 21, 22, 22, 23, 23, 24, 24, 25, 25, 26, 26, 27, 27, 28. Okay, and so on. Okay, so once J is completed, I can start the task number D. For how much time? D is for 7 unit of time. So 1, 2 time, 3 time, 4 time, 5 time, 6 time, and 7 time. Okay, so D is done. Next, what we have to do? Okay, once B is completed, you can start E. Where you can start E? E can be assigned to the second one. So you can resume the work from here. E for how much unit? 9 unit. So 1, 2, 3, 4, 5, 6, 7, 8, 9. E is now completed. Right? E is completed. So all the tasks are completed for application 1, application 2. So now where J is completed, J is completed at this particular period of time. Then you can start K and L. K is assigned to second one, but second is not free. Second will be free here only. So I can assign K here, another K here. So let me write here 28, 29, 29, 30. Okay. So now K is completed. L can be assigned where? L can be assigned in the third one. So if L is assigned in the third one, okay, K3 is over. L is assigned to the third one, means 4 unit of time. So what we can do? L we can start from here. 1, 2, 3, and 4. Right? So what we can say here? So this is the completion of all the tasks. So there is a concept called total completion time. Total completion time of all the tasks. All the tasks. That is called as max span. Max span is called as total completion time of all the tasks. So you can see here at what time all the tasks are completed. All the tasks are completed at what time? Tell me. At what time all the tasks are completed?
30 seconds.
30. Okay. So you can see cloud 1 case, all the tasks, those tasks are assigned to C1. They are completed at 28 unit of time. C2 case, they completed it 30 unit of time. C3 case, they completed it 25 unit of time. So make span is nothing but maximum of C1, C2, C3. So you will get 30. Okay. Make span is 30. Now you have to find utilization. Utilization, the formula is local make span or individual cloud make span divided by overall make span. For example, if I say C1, find the utilization of C1. So it is nothing but 28 divided by 30. Okay. For C2, it is 30 divided by 30. That means 1. 1 means it is equal to 100%. Right. C3 case, it is 25 divided by 30. Okay. And if I ask you average utilization, then you can say 28 divided by 30 plus 30 divided by 30 plus 25 divided by 30 divided by 3. So that will give you average utilization. Or you can write in percentage also. Like I have written 1 is equal to 100%. Okay. So this is utilization. Similarly, there is another parameter that you can calculate that is called as idle time. So let me erase this thing. Okay, so if I ask you to calculate the idle time, so determine the idle time of cloud 1. Cloud 1 is idle here, 1 unit, 2 unit, 3 unit. So cloud 1 is idle for 3 unit. Idle time of cloud 1. Cloud 2 case, it is idle for 1 and 2. Then it is busy rest of the time. So 2. Cloud 3 case, it is 1, 2, 3, 4, 5, 6, 7. 7 unit of time. Right? Then you can calculate average idle time. It is nothing but 3 plus 2 plus 7 divided by 3. How much you will get? 12 divided by 3. It is 4. So you have to calculate make span, utilization, and idle time. So these three parameters, okay, through which you can assess the performance of a particular scheduling algorithm. Okay. But what is the drawbacks of this algorithm? Can anybody say? What is the drawbacks of round robin? And one thing you can remember here, there is no turnaround time. Okay, there is no time quantum. In the process building, you know the concept of time quantum. After that, you are switching from one process to another process, right or not? But there is no such concept here.
Excuse me, sir.
Yeah, please tell me.
So from 20 to 29 and 29 to 30, cloud
Yeah.
1 is not idle.
No, it has completed its work here. That's why I'm not considering as idle time.
Okay, sir.
It is also completed here. That's why we are not considering idle time.
Thank you, sir.
Yeah, yeah. Okay. So there is no concept of time quantum in that way. Round robin is different. But what is the main drawbacks? The main drawbacks is that, for example, if you see here, B is executed 8 unit of time, right? That is assigned to cloud 2. But if B is assigned to cloud 3, so it will take how much time? 4 unit of time. Similarly, C is assigned 8 unit of time. If C is assigned to second cloud, it is going to take 3 unit of time. Right or not? So there is a issue, right? Because you have a predefined order, that is 1, 2, 3, 1, 2, again 1, 2, 3, 1, 1, 2, 3. So if the order is predetermined, there is no use of this particular matrix. You are not analyzing the matrix. Only you are choosing the values in round robin order. Right? For example, you are choosing this order. Like I am choosing this 2, 8, 8, then this one. This is your first application. Then again this one. Then again this one. Right? Like that order you are choosing. Right or not? But you are not looking into other alternatives. Right? Whether these alternatives are good or bad, that is different thing. But you are not looking into that alternatives. So that is the main drawbacks of this particular algorithms. So what you can do, you can avoid it by using the second algorithm, that is called as least scheduling. So in the least scheduling case, what you have to do, so let me erase the whole things. I hope you have copied. Okay. So least scheduling case, what happen? You have to choose the minimum one. Although the solution is written here, you can see round robin case, you have followed this one. 1, 2, 3, 1, 2, 1, 2, 3, 1, and 1, 2, 3. This one, this row. But least scheduling case, you will find the minimum of these three. Minimum of these three is 2. So it is assigned to 1. Minimum of these three is 3. So it is assigned to 3. Minimum of these three is 2. So it is 2. Minimum of these three is third cloud. So it is third. So minimum of these three is again third cloud. So it is third cloud. Minimum of these three is second cloud. Minimum of these three is third cloud. Minimum of these three is first cloud. Minimum of these three is first cloud. Okay, there is a mistake here. So you have to assign to first cloud. Minimum of these three is second cloud. Minimum of these three again achieved in the second cloud. Minimum of these three is assigned to one node. So with respect to the precedence constraint as well as mode, you have to evaluate the same algorithm. Okay, you have to evaluate the same algorithm using list scheduling. And in list scheduling also case, what you have to determine? You have to determine the make span. That is, local make span also you have to find for each and every cloud. Overall make span also you need to find. Right? You have to also find utilization. Individual utilization also you find, and you also find the average utilization. Similarly, you find the idle time and average idle time. So please solve it. Take these three clouds. I told you one example with respect to round robin, right? Round robin case, you have random order. But in this case, the order is decided whether to choose cloud 1, cloud 2, cloud 3. That is based upon the minimum of 3. Minimum of 3. Okay. So you know minimum of 3 is already given here, except this one is wrong. That is, you have to take one first cloud. Solve the same problem and tell me what is the make span, utilization, and idle time. Okay, all of you solve it. You draw a Gantt chart like the way I explained the round robin algorithm. You solve this problem. And check the performance, whether the performance is better than the round robin or not. That you have to also check. Okay, with respect to a given example, you have to decide whether round robin is better or this least sibling algorithm is better. That you have to determine. Okay, let us stop here and you try to solve it. In the next lecture, I'll tell the solution and we'll compare your solution with my solution. And also, this is the first one you have to do. Second one, you have to think another algorithm which can improve the performance. Like I choose the minimum one. Similarly, you think about the solution which can improve the least sibling also. Right? Like you can see here, least sibling is performing better than the round robin algorithm. Similarly, you think another algorithm, okay, your own algorithm, which is better than the least sibling algorithm. Okay, that we'll discuss in the next class.